Okay, so before we start, there are certain terms which you all might have heard of. Those terms are there on your screen. So if you are anywhere related to security infrastructure in your organization, or if you are interested to learn more about security, these are the terms you should be knowing. These terms start from the very basics like operating system, software, virtual machines, virtualization, and then goes into very enhanced topics like your data protection, IPS, IDS, information assets, personally identifiable information, and then security compliance requirements such as GDPR, HIPAA, HITECH, MAS, IEEE, ISO standards, etc. And on the left side, you have some very basic component of any network. Any network will obviously have firewall, email security, computer networks, virtual machine, etc. So these are the couple of things you should be knowing before you start this topic. Even if you are not aware of it, then you should start searching these topics on the Google and learn more about it. The more you know about it, that's where you will get more understanding about the security on the cloud, how what's missing in terms of securing the cloud, and how you can secure your cloud infrastructure with help of this technology. Okay, so before we start talking about securing the cloud, first we should know what are the basics of cloud, what is cloud, and how it is different than your organization's on-prem infrastructure, right? So, a cloud computing definition, as per an IST definition, cloud computing is on-demand availability of computer system resources such as your data storage, compute power. um, Data storage is your memory and your hard disk space, and compute power is your CPUs. So basically anything which lets you subscribe to a computer on the internet without actually running it on a physical machine. So for example, if you need a virtual machine which should be having 16 core of CPU, 16 GB of RAM, and then thousands of GB of disk space, then you can just go to AWS or Azure and create a virtual machine and run your workload there. You don't need any physical infrastructure for that. Now that's the easy part of it, but then it can enhance more. Then further it goes into like what kind of deployment models you can select, what kind of cloud services are there, what are the characteristics of a cloud. So those are the things you should know before you start using a cloud, and before you even think about securing the cloud, right? So other than definition, we have types of cloud computing deployments. There are total basically two high level of cloud computing environment, public and private. And then you further have two more categories. So public cloud is anything which is available for everyone, like your AWS, Azure, Google Cloud. And private cloud is owned by an organization or an corporation by their personal use. For example, a bank might be having its own cloud infrastructure to host its own servers. So you might be going to icicibank.com and they might be running thousands of server on their own data center or their own cloud. That's private cloud. Hybrid cloud is nothing but a combination of both, where an organization runs both public cloud and the private cloud in their environment. So there might be requirement where you might want to host certain part of your infrastructure on public cloud and certain part of infrastructure on private cloud to make sure you are adhering to your corporate standards and compliances. So that's about hybrid. And then community cloud is again, it's similar to public cloud, but it's restricted to a specific community. So for example, a healthcare provider can create a cloud which is only available to all the hospitals, and there may be specific requirements on that particular cloud that any patient information should always be encrypted, patient information should be stored but never revealed, and there can be a lot of specific controls on that particular cloud. So these are the community cloud where it's maintained, managed, and used by a specific community. Next is types of cloud services. So there are like four type of cloud services usually, but the term which is there, serverless computing, you will not hear that very often. So we'll talk about that as well here. So type of cloud computing, cloud services are divided into four categories. If we talk about these terms in a very layman language, um, infrastructure as a service is a service where you run your infrastructure, means your CPU, your memory, your disk space, your firewall, your email security, your network connections, right? Those are the infrastructure devices, and then your containers, Dockers, etc. So any service provider which allows to create virtual machines, allows you to run Dockers containers, allows you to run on-demand services and create a scalable environment to adhere to your requirements, that goes into IaaS. So here, the more the responsibility in terms of securing your infrastructure is more on the customer themselves, because you have full control other than the underlying hardware. Then you have platform as a service. Platform as a service is more specific, where you just have a platform like a Docker or a container or an application-based infrastructure. So, for example, if you look at it in a layman way of looking at it, is that in infrastructure as a service is an operating system, and platform as a service is actually running a MySQL server on that server. Okay, and then software as a service is running a website which is using the MySQL server as a backend, right? So similar thing happens in the cloud as well. Your Dockers containers are part of platform as a service, and then and as part of the software as a service, you have different vendors in the market which provide you softwares as an on-demand or pay as you use license model. So a couple of typical example of software as a service are like Salesforce, Office 365, Box.com, Google Drive.com, right? These are the couple of software as a service where you purchase the subscription based on per user or the space wise. Now, there's one more interesting term called serverless computing. So, as we talked about infrastructure, where you run the operating system, hard disk space, and etc., then you have platform, you have software. But let's assume that you don't need any of these. You just have a script and you just want to run that script whenever you want. It might be a Python based script, or it might be a Perl based script, right? So your requirement might be that whenever someone tweets you something about your company, you may want to run a particular code, right? And then that code should be just should be able to respond to the customer directly. You don't need any large infrastructure for such kind of scenarios, where you can have serverless computing in place. So two examples for serverless computing are Amazon Lambda from AWS and Microsoft Power Automate. These are serverless computing services. Then what are the characteristics of cloud computing? Typically, any data center before declaring this as a cloud, you should have these characteristics in there. On-demand self-service. This is like whenever you want, you should be able to create a VM. Whenever you want, you should be able to delete a VM, and whenever you want, you should be able to allocate more resources to that particular system, right? And this system should also be able to scale themselves. And what is the scaling? Scaling is like increasing the resources on the same server or creating more servers. So for example, if you look at Flipkart, so Flipkart usually has very a normal customer flow to their website, but during the sale period, the big billion days and all, they expect to increase load on their servers, right? So there, they have automated backend policies where, depending on the how many users are hitting their website, what is the CPU utilization of each server, the number of servers increases by itself when the requirement increases, and the number of server goes down when the requirement decreases. Same happens with the resources as well within the server. So the memory and the CPU goes up and high as per the requirement. More CPUs are allocated to a particular VM, and more memory might be allocated to a particular VM as per requirement. So this is an example of elasticity and scalability. The second point, they have broad network access. So this means you should be able to access your cloud environment from anywhere. You should be able to create VM from anywhere just by using your browser or a PowerShell. Any sort of device should be able to support this requirement. Like you should be able to create a virtual machine from your personal laptop, your corporate laptop, your PDAs like your tablets and your mobile phone, etc. Multi-tenancy and resource pooling is the next point there. So in a public cloud, as you know, there might be multiple companies or multiple customers using the same cloud. So for example, I might be running a VM on a public cloud, and then user B might also be running their own server on the same cloud. How do you differentiate between the data? How do you make sure that the user B doesn't see my data and I don't see his data? If I don't have access to his VM, he doesn't have access to my VM, right? There has to be a segregation of in terms of how the resources are created, how you can access your resources, right? So that's called tenancy. Every user has their own tenant. Whatever you do in your own infrastructure, in your own account, that's limited. There is a boundary called tenant, and you just have access to your tenant, so you cannot access anyone else data or resources there. That's called multi-tenancy. And resource pooling is nothing but combining more resources into a single identity, as I said, tenancy. So you can create like multiple VM virtual machines, and then you should be able to create a scope of those virtual machines. Like for example, you have a front end servers, you have back end servers, and you have mid-tier servers. So you should be able to scope them into different categories, resource groups, etc. And then you overall scope is your tenant level scope. Measured service, the last point. Measured service is a big critical characteristics for cloud computing. Measured service means you only pay for what you use. For example, you have a server, and on that server you have a hard disk space, right? And some of the cloud providers only charge you for the amount of data you store on that hard drive, not for the entire hard drive space. So for example, you have 1 TB of hard disk space and you are storing just 100 GB of the data there. You should only be paying for that 100 GB of utilization, not for the entire 1000 GB of space. So that's measured service. Similarly, you might be creating a VM, and that VM you usually keep in the keep that VM in the shutdown status, but you when you require you turn that on. So you should only be charged for the compute power when you use. Should not be paying for the compute power when the server is in terminated or shutdown state, right? But you will of course be paying for the disk utilization and other parts where the resources are located to you permanently. So these are the characteristics of cloud. These definitions are very important for you to know the cloud, and then before you start looking at securing the cloud, right? Now, if you have paid attention, we are more talking about here in terms of what is cloud, how do you create a server, and then what are the different types of mode you can deploy the cloud, right? And what are the cloud services. The reason talking about all of this is that you should be aware that what kind of clouds are there in the market today, and why a centralized console is required, right? Because you need a solution now which secures your public cloud, your private cloud, your hybrid cloud, your community cloud, which secures your infrastructure as a service, your PaaS, your software as a service, all these things, right? So there's a requirement of a centralized console or a centralized solution which does all of this, and that's why CASB. We'll talk about that more in upcoming slides. So this is an interesting topic, defense in depth. Before we talk about CASB, you should be knowing about it. I'll give you a few seconds to read what's there on the screen, then I'll explain you. Defense is in depth is a terminology to ensure that you are securing your data and your infrastructure and everything at every layer possible. So I'll give you an example that you have a server which hosts certain data, like maybe you are a banking website, right? You might be having customer data, credit card numbers, or different data which is sensitive in nature. So when you receive this data, at what all security parameters you should be looking at, what are the things you should be securing, right? So defense in depth is a terminology, or is a way of securing the data, that you secure the data at every possible layer. So if you are aware, there can be, if you might have heard of OSI layer, the model, or TCP model, right? There are like 7 layers in the OSI model, and then 5 in TCP model, right? So in each of those layers, how do you secure data? How do you secure the data when the data is accessed by the application? How do you secure the data when it is there in the CPU or the buffer? How do you secure the data when it is in the transit on the wired or wireless network? How do you make sure that the data is secure within the organization, and how is the data secured when it leaves your organization? How do you make sure that only authenticated users should be able to read the data, not unauthenticated? How do you ensure that you only see the data what you are supposed to see? And final is that how do you make sure that only authorized users are allowed in your data center, right? So these are the layers of security or defense which you should be looking at. If one mechanism of this fails, then the another one takes care. So if you look at it, this is a layered architecture here on the right side, right? And if you start from the bottom, on the bottom you have a data which you want to secure. So this might be your credit card data. So you first thing you do, you make sure your data is encrypted, and only the person who's supposed to read the data has the access to the keys, encryption decryption keys to read the data. That's the first layer of defense. Then you have application layer. On the application layer, you again put controls in place that the only the application reads the data. A user or an administrator should not be able to read the data. This is very important because on a server you might be have running an application in Apache server or a front end website, and an administrator might be logging into that particular server to do some troubleshooting. At any point of time, the administrator should not have the access to data even though the application is processing the sensitive data. So this is very critical. How you process the data. The data is encrypted. The application is storing the data in an encrypted format. Whenever it's in buffer, the buffers are stored. The application never stores the clear text information on your hard drive, etc. So there are multiple things you should be looking at. And once this data goes into, like, let's say the application gets your credit card data, then the data goes to your memory or your CPU, and you again make sure that your buffers are not readable, those are protected, and you have all the encryptions in place. Then the data goes to network layer, and so forth. You have the security on each and every layer. If you have any questions on this particular slide, please drop them on the chat and we'll talk about that at the end of the session. Next one is CASB. So here we actually talk about CASB now. So CASB's definition, a CASB is a cloud-based solution which either sits on your on-prem or in the cloud, which acts as a perimeter between your on-prem resources and the cloud resources. Okay, so the definition, what it says is the CASB is an on-premise or a cloud-based security policy enforcement point placed between the cloud service consumers and the cloud service providers to combine and interject enterprise security policies as the cloud-based resources are accessed. What does it mean? So take an example, an employee might be sitting in your organization. You might be using several cloud services. You might be your marketing people might be accessing salesforce.com, and your IT people might be accessing OneDrive.com, right? So there may be different users and different use cases are there. So you need a solution. The CASB solution, what it does, it connects to all these services through API or the reverse proxy. And then whatever data you upload, download on these services can be monitored. Whatever resources you create on an IaaS-based infrastructure, that can be monitored. Whatever users you create, whatever accounts you create, that can be monitored. And whatever activities you are doing on this cloud can be monitored through a CASB solution. I'll give you a real life example that a user stores a credit card data on OneDrive, the OneDrive account which is owned by the organization. Now you just want to make sure that OneDrive accounts never store any Aadhaar card or the PAN cards in plain text. So you use CASB, create a policy and enforce those policies to make sure that anytime when a PAN card or Aadhaar card data is uploaded to OneDrive, that's either deleted or encrypted. That's what you can do. And this policy doesn't apply to one service. You can create the policy and apply to multiple different services. So it's a centralized console. Now, there are a couple of things which CASB does. So this is one example of what I just gave you. That's called data leakage protection or data loss prevention. It's one of the most common use cases used by the CASB solution by different organizations. Then you have more. You can get more details from CASB. One is like what your users are doing on these cloud services. Like your user logs into OneDrive, uploads a file, downloads a file, deletes 10 gigabyte of data, logs into another user's account, modifies their permission. All of these things can be monitored. And the CASB also has very interesting thing which is called machine learning algorithm. It tracks your usual behavior. It creates pattern about how you access your network. So for example, if you are logging in every day from India and you never logged in from China, and suddenly one day you log in from China, CASB can detect that behavior as an anomaly and will trigger an alert to administrator that we have seen a different behavior with this account. Probably this account might be compromised. Just an indication of a compromised account. It's not guaranteed that the account might be compromised. The user actually might have gone to China and then might have accessed the service from there. But these are the scenarios which administrators can investigate. There can be more scenarios like in terms of how many times a day you log in or stay active on the service, and suddenly one day you are logged in 24 hours and you're continuously downloading data. That's another machine learning algorithm requirement, and it can display alert for such activity. And if you are logged into from two different geographical locations, one from India and one from US at the same time, being human, it's not possible. So it's another possible indication that your account is compromised. So these are called user behavioral analysis. And based on that, CASB shows you different alerts, creates different alert for administrator to investigate such accounts. Then determine the risk of unapproved services in your bank, in your organization. So there might be scenarios like so there's another thing which CASB does. CASB actually connects with your perimeter devices, your web proxy solutions, and your firewalls. CASB. So what happens in a typical real world scenario? What happens? You access any cloud service or any service for that matter. You always go through a router in your home network, and when it's your corporate network, you always go through a firewall or a proxy, right? So a proxy or firewall always knows what you are accessing, how much data you're downloading, how much data you're uploading, and when you are doing this activity, right? So this data can be fed to CASB, and then CASB can do further analytics on this and show analytical reports that these are the services, these are the cloud services being used in your environment, and this is the amount of data being uploaded and downloaded, right? So there may be scenarios where you are not aware of a particular service being used in environment, and that might be risk to your environment. For example, a user might be using in a PDF converter, right? And might be uploading confidential data there. So you may want to block such services, and getting visibility into those things is done by CASB solutions. So that's about the CASB capabilities and the definitions. Then CASB gives you more controls. It almost touches all the topics of security. On the right side, we have the capabilities listed. And in the scope of this call, it's not possible to cover all those things because the topics are very vast and require detailed discussion on those. So how CASBs are designed? What are the basic core pillars of CASB? These are called pillars. So there are four pillars of CASB. A CASB solution which is available in the market has to provide you these four capabilities. If the solution lacks any one of these capabilities, it is not a true CASB solution. So these pillars are just identical to like any pillar you have in your buildings as well, right? If you remove one pillar, the integrity and stability of that building goes away. Same thing happens if a CASB solution you purchase doesn't have any one of these pillars or features in there, then you are lacking controls in your environment, and it's not truly a CASB solution. So when you purchase a CASB solution, this is what you should look at. You should ask the vendor, what are the pillars your CASB solution supports? Does it has data security capabilities? Does it has threat protection? Does it have compliance controls, and does it have visibility? I'll explain in a very brief. Data security is making sure that your data is secure on the cloud. Means whatever data you upload to OneDrive, Google Drive, etc., is always secure. You can create policies like as I gave example earlier. You should not be able to store PAN and Aadhaar card on the cloud services. That's part of the data security. Then more, there can be more scenarios in terms of data security. You should be able to encrypt the document when required. You should be able to read the encrypted documents and apply classifications properly if not classified properly, right? So there are a couple of examples of data security. Again, data security is a very vast topic. There are a lot of things we can do in this particular area. And a typical organization which adopts CASB, always this will be the primary use case, data security for the cloud. This is where it all starts, and you go into further use cases to utilize it more. The next one is threat protection. Threat protection is nothing but as I mentioned earlier, that machine learning based algorithm which allows you to detect difference in your users daily activity behavior pattern and then identify if there is any threat, right? That's one way. And second, there may be malware or viruses, so detect those and prevent those on your cloud environment. Third one is compliance, making sure that you are compliant to regulatory compliance requirements. So for example, if your organization is in the Europe or Germany, then there is a regulation EU GDPR which every organization has to adhere, right? So that's a compliance requirement. Using CASB, you should be able to do that. The last one is visibility. Getting visibility in terms of what your users are doing in your organization and the specific cloud services. That's what is the visibility about. As I mentioned earlier, that you should be able to find out who is accessing a particular cloud service, how much time he has used, how much data he uploaded and downloaded. So that's a visibility. So typically, what organizations do in terms of visibility, they run a report every week, find out who are the users accessing unapproved services, and then take action in terms of blocking those particular sites, making sure that users cannot access whatever is not approved. All right. So pay special attention to 4 pillars of CASB in your trainings or in your real world uses. Without these pillars, a CASB solution is incomplete. Okay, last one, top CASB use cases. Here, so CASB use cases, as we already discussed about the use cases like gaining visibility into what is being used in your environment, data protection policies, encrypting data, right? And identity access based control. So this is an representation about how organizations feel that these capabilities are important. So 49.2% organizations feel like this is a data, this is a survey done by one of the organizations who provide CASB solutions. They have done this survey with their customers and to find out what are the features their customers are feeling are important, right? So as part of this survey, two use cases were very highly required by all of the users: data loss prevention policies, the second one, and then the fifth one, which is view detailed audit trail of all users and admin actions. So of course, as I mentioned earlier, the data loss prevention or data security requirements are the biggest use cases of CASB. That's where the adoption starts. And next one is audit trail of users. As I mentioned, what users are doing when they are logging in, logging out, how much data they're uploading, downloading. If they log into somebody else's account, manage their permission. These are the things which are required from the forensic investigation perspective. So for example, tomorrow, if something is leaked from an organization, there was a data hosted on OneDrive account and suddenly the data was leaked outside. In order to find out who might have done it, you need to do detailed analysis, like who all users have access to that particular document, whoever had access, what activities this guy did he download the data, did he upload the data elsewhere, right? Since CASB is connected to multiple cloud services, you can find out if the user was trying to upload the data to different cloud services. So these are top two use cases. Then you have other use cases which is coming around 50% more or less, right? Which is your shadow IT discovery, encryption, your policy-based control on the devices, like making sure that only corporate devices can access data. And then the last one is detecting insider threats. Insider threats are very big problem for an organization, right? You can prevent an external attacker through firewalls and your proxies and all, but how do you prevent a malicious user sitting inside your organization? Or how about a hacker already having access to one of your server? So CASB looks into those things. So as part of Shadow IT or the audit trail, you can get more visibility in terms of activities done by any suspicious machine or suspicious user account, and then remediate those things. So these are the top CASB use cases. Of course, each use case is very vast in nature itself, and we can spend a lot of time on this to discuss. So if you have any specific use cases which you want to discuss, or you have any questions on any specific use case on this slide, please drop those questions on the chat. Again, I want to explain this slide again. It's a repetitive content, but wanted to show you like what are the top CASB use cases and how do you align those with the 4 pillars. So what is there in the visibility? What is there in the data protection, threat protection, and compliance? We have already discussed about it, so I'll just pass this slide. Okay, so moving on to the next slide here, CASB deployment models. So there are 4 CASB deployment modes. Typically, the first 2 are the mostly used and easy to deploy modes. And then the reverse proxy and forward proxy, those are advanced integration methods. Okay, let's see how they look like. Log collection architecture. So log collection architecture is the shadow IT visibility as we discussed earlier, that you have users accessing cloud services from your organization. They go through your corporate proxy or the firewalls, and then you get that data from your proxy or firewall, as you can see here. So here you have on-premise user. This user is accessing cloud services here. So you are going through web proxy and firewalls, and then what happens, your web proxy and firewalls send this data to an on-premise based software or a server. This server collects the data and uploads the data back to CASB solution, right? This is for the on-premise user. And for remote users, your users will go through your corporate proxy and those data will be sent to your CASB solution. So somehow your CASB solution gets the data, and then your CASB solution can tell how much time a user spent on Facebook, how much time did a user spend on the Instagram, how much data he downloaded, how much data he uploaded, right? So this is a typical architecture of log collection. It's called shadow IT discovery. Shadow IT discovery is very important for any organization. Why? First, what it is, shadow IT discovery is like identifying any unapproved IT services being used in your environment. It may be using a pen drive and connecting it to your corporate laptop is known as shadow IT. Printing a document, right? Using your personal printer is a shadow IT. Using a public website and the cloud service is also called a shadow IT, right? So here in terms of CASB, we are only concerned about cloud services. Okay, so shadow IT visibility is very important, and you should pay special attention um, to this along with your corporate proxy logs, because your corporate proxy logs are raw logs. You cannot read them, and reading them is quite difficult task. So CASB solutions read that data for you and creates beautiful charts and graphs for you to read and analysis those data in real time basis. So these reports may refresh on real time basis or once in a day or once every 2 hours. Okay, so the next one is API architectures. Now API architectures are like how to connect, how to see what your users are doing on this cloud service. Like a user might be doing certain activities on Office 365, Salesforce, AWS, etc., right? And when they log in, when they log out, what happens? So a user typically in this architecture always access the cloud service directly. The CASB solutions are not in line. So what happens? You log into OneDrive directly, you upload the data, you download the data, you edit the data, that all you do directly. But then the cloud service is connected through an API connection to the cloud service, and whatever activities you do, this cloud service will send an update to the CASB solution that Ilyas logged into salesforce.com and he uploaded a data called credit card docs. And this is the content. CASB solution will scan the document and will tell that particular cloud service to remove that document. So as you see in the both cloud, in the reverse proxy and the log collection, we are not in line. We are just getting the feed indirectly from the proxy solutions or your cloud services, and then running analytics on that data, right? Or executing action passively on those particular. But how about you want to block something in real time, right? APIs are not real time, because what happens, you upload the data and then we delete the data using the policies. That's not always the best case scenario. There may be certain critical information which you want to block in real time. As soon as the data is uploaded, it should be blocked. The data should not even leave your organization's network, right? In that case, you implement the solution like that, that whenever a user wants to access Salesforce, you go through CASB, and from CASB, you go to Salesforce. So in your browser, if you type onedrive.com, you will be going to onedrive.casb.com, and that's called a reverse proxy environment. In that, anything you do on that cloud service, you log in, log out, upload, download, everything you are doing through that particular reverse proxy. And now assume you upload a document, so CASB can see that in the real time and block it for you. Okay, so in case of forward proxy, it's the diagram still remains same. It's just the authentication and traffic redirection is different. I don't want to get into that for now. I want to keep it simple. So reverse proxy and the forward proxy is almost same. The behaviors are same. The working way is same. But reverse proxy is more preferred for the, because the authentication is much easier and it's easier to implement the forward proxy. Forward proxy again requires much complex integration like proxy chaining. It's like which is not possible to cover in such short time. Okay, so that's all from my end.